Hello everybody and welcome to exercise 2. We are looking at the top of page 25 here. Let's read the instructions on this. So they'd like us for each of the following determine whether or not the set S in the vector space V is linearly dependent and justify our answer. And then if it is linearly dependent, could we find a dependence relation? Okay, so in this video we're going to just be looking at part A here. So it gives us a set S equals 1 and x, and the vector space looks like this. Now, I don't know that we've talked about this notation in a while. Okay, so recall what that means. This is a set of functions. Okay, so this notation means functions with domain R+, which is the positive real numbers, and codomain R. Okay, so it's kind of an interesting question because it's asking us whether or not two functions are linearly independent. Okay, well, we're going to start this question the same way we always do, from the definition. So to answer a question about linear dependence or independence, we start by forming a linear combination of our functions and setting it equal to 0. Okay, so a times the first function plus b times the second function is equal to the 0 vector. And what do we mean by the 0 vector here? Okay, remember we're talking about functions, so the 0 vector is actually the 0 function. Okay, in other words, the function f of x equals 0, a horizontal line. Okay, we're going to be kind of referring back to this equation, so I'm going to give it a name and just call it star. Okay, now here comes kind of the critical step. What do we do with this? Okay, the question that we're really trying to answer is what kinds of solutions can we get to star? Okay, could there be non-trivial solutions, or is only the trivial solution a solution? Okay, well, the key here is remembering what we're dealing with in this vector space. These are functions, which means that the x that you see in that equation or this equation has to be true for every x in our domain. I'm going to write that down because that's kind of the key observation here. Okay, so since star is true for all x in R, it allows us to choose any value, any real number x, and come up with a true statement. So I'm just going to pick a couple of reasonably nice x values. What's your very favorite number? Okay, my favorite number right now is x equals 0. Okay, because if we take that and substitute it in, we're going to get a really simple equation. So we'll get a times 1. Okay, and I'm looking back up here and just substituting x equals 0 in, plus b times 0 is equal to the 0 function. Okay, oh, and actually, we substituted a number in, so actually we're talking about scalars now at this point. All right, what does that simplify to? Well, b times 0 is 0, so that tells us that a has to be 0. Okay, we now know that in order for equation star to be true, this has to happen. A has to be 0. Okay, but again, since we know that star is true for any x, we're free to choose another x if we want to. So how about x equals 1? That's also a pretty nice number. So if we substitute that in, we get a times 1 plus b times 1, okay, which is just b is equal to 0. And notice that if we solve that equation, we get b equals negative a, but we already showed above that a has to be 0, so b is 0 as well. Okay, so what did we just show here? Well, we showed that the only solution to equation star up here is a equals b equals 0. In other words, the only solution is the trivial solution. So since a equals b equals 0 is the only solution, okay, and that's the key word, only, we see that. Can you complete that sentence for me? Okay, that's the definition of S being linearly independent. Okay, so we just demonstrated that this set of two functions Right? There's no dependencies in that set. Those functions are independent of each other.